Hey everyone, so it's been a while since my last video. Been busy with work, which was good because, you know, it's good to make money. But with the holiday season here, my clients are all off for about 2 weeks, so it gave me time to jump back on my WRX project. So here in this video, it's not really a tutorial, it's kind of like a project overview breakdown, but a lot of it is actually focused on the 3D scanning side, which is right now the most important part to a good results project, if you will. So in this series, I'm focusing on the side skirt. Now, when I scanned the whole car, the side skirt was off because I didn't really need it on the car, but I do want to make sure when I scan this, I have all the OEM brackets in my data set. So I want to make sure that from the bottom, I have the ability to use these holes right here for mounting the side skirt. And then from the inside, I want to make sure I have all these little brackets, and you'll see in the video where I'm scanning. And so I'm just doing iStar2 laser mode, and as you can see, a bunch of markers are needed. So this was my side skirt, really dusty. If I was to do it again, I'd clean it. These markers are literally dropping off left and right, but I thought it would help as a free doling spray. I don't think it was necessary because the laser mode does scan black parts no problem as long as markers are good. So this was the side skirt, and now this is the result. So this is the final one, the first prototype, if you will. And from the back, as you can see, we have everything just like the OEM one. I have all the hinge brackets for mounting, as well as all the bottom base points. So when I like to design my parts, I like to be able to make it as OEM as possible, so that way it's kind of plug and play versus having to use the screws. I forget their name, but I think it's like a set screw or something where it just forces its way into the car, which I don't want. I want to be able to utilize every OEM bracket or mounting point possible before I have to add additional support. So this is version 1, very thin printed side skirt, but as you can see, it's quite obnoxious. So I have like a GT3 RS inspired front blade. I have a little shark fin in the back. It's got a lot going on. So what I'm gonna do is I'm gonna throw it on the car right now to kind of see how it fits. I have not tested it yet because I didn't know if it would break or not, because all I did was do some hot welding of the plastic on the back. So I'm gonna put it on the car. If all goes to plan, it's gonna fit pretty darn well. And then I'll start the video with the breakdown of the project, from the 3D scanning to the aligning to kind of an overview of how I did the modeling. So that's that. I'm gonna put on the car and then I'll record a new session from there. All right, and there is the side skirt on the car. I'm using every single OEM mounting point. And for the most part, it's pretty solid. I mean, this part's flimsy, and I'm not using this clip. I forgot to add the hole on the 3D model, but other than that, it's pretty sturdy. And there's, if I remember, there's another pin right here, but yeah. For the most part, fitment's great. Still open the door. And same thing up here. And I think this could even be used with the OEM fender with no issues. But that blade is designed to blend in more with the wide fender once I have it on. And then that way you'll have the wheel out and some of that tire visible through the backside. But overall, it's a success. First one out, and it fits like a glove. The first thing I have to do is I throw a bunch of markers on here. And if you see the car in the background, they're really tight. Because of how I'm seeing laser mode work, the closer they are in terms of grouping, the easier it is to transition from one segment to the other. So it might be overkill, but to me, it's amazing. Like, it's just buttery smooth. There's really no tracking lost. The alignment's great. So I'm gonna throw a bunch of markers on this, and you'll see, and I have a pack. Like, I just buy them from some 3D scanning website. So I just have a bunch of markers to play with. I mean, they're hard to get out, but I need to say a huge wad of them. So I'm gonna throw markers all over this, and that should finish up my markers for this project. So I have more than enough. Now that all the markers are somewhat applied, I figured I'd do a little walk around and explain the, the logic here. So as I mentioned, I like to do a lot of overlapping, and the reason why I did not clean this off, because you can see there's a lot of dust and crap all over it. My logic is this is like free dulling spray, because even though it will scan, and it actually scanned very well on my black parts on the car, if you could help it do better, faster job, why not? So the thing is, on the backside, I don't really need all the guts because it's a 2D object, if you will. So whatever's on the side underneath that I scanned, I could just add thickness. This will be good. But I do want these areas, and I do want to make sure that I know exactly where they go on the side skirt outside. So that's why I did put markers here, and I hope as I'm scanning, I could gently flip over and it will track. That's my goal. We will see how well or not well it works out, but that's what I hope for. So now what I'm gonna do is I'm gonna start scanning before these things start dropping. And again, it's got dust all over it. That's why the adhesion isn't the best. If I cleaned it with rubbing alcohol and stuff, it would have been the smarter choice. But I just want to see if I could get free dulling spray with the dust particles and such. So anyhow, I'm gonna start scanning and we'll see how smooth this process goes, because I want to capture the front face, the bottom, and then the inside guts, and then see how much I need to align or how much I could get done in one scan. So I'm gonna hit record here in a second and we'll just kind of take a look at how it goes. All right, so now that I'm on the computer, as you can see, we have quite a messy scan, and if it does what it did on the car part, this isn't that big of a deal. So when I do generate point cloud, it might clean it all up. If this one doesn't, the optimized generate point cloud does. So we'll take a look at it here in a second. Okay, so now, as you can see, it cleaned it up. I mean, it's not flawless, but I think for what I need, this is fantastic. So what I'm gonna do now is just select connected domain, and hopefully it does what I want it to do and not have the bottom boxes. Perfect. So see, that's why I have it on the boxes, so it kind of hovers. I'm gonna invert it, delete that. So it cleaned up all those weird floating artifacts. As you can see, our hero surface looks fantastic. So this is good. I am very happy with this. So now what I'm gonna do is, now that this is in a good spot, I'm gonna capture the guts of the side skirt, which is all the, hopefully I'm gonna be able to get away with capturing where all the mounting brackets go. And yeah. All right, I did several recordings and ran into tracking issues, but this is now a solid foundation. So what I did was I used these 3D printed little triangle pieces that have markers on them. So I'm using these, tossing them in here, and I'm put that one back over here. Then I put random parts from the car, little door hinges, broken plastic pieces, put markers on them to help establish more 3D tracking features because it's such a deep cavity. And then through some of these tiny little dots that comes with the OnStar 2, they're very small markers. I threw some of them on the actual brackets. So I did a little test and it will work. It does scan just fine. So now I'm gonna go and start scanning and capture this whole inside, and then that should work well. Now, when I was doing a quick test, I had an issue with the tracking skipping, and then it started scanning in a different area. So what I'm gonna probably do is just scan half of this and then the other half just to preserve, because there's no rewind button with laser mode, at least not for the OnStar 2 in X-Star Hub. So I have to kind of find ways to work smart, so that way I don't risk having to delete and restart all over. So I'm gonna just focus on scanning half of it, then the other half, and then we'll align it all because I know that will work just fine. So let me grab the scanner and start a new recording. And like I said, I'm only gonna focus on half of the side skirt right now. So I have these two white door hinges. Those are gonna be my reference markers. So as long as I overlap them, that will give me enough information for alignment. So there's that. Okay, so here's the scan. As always, it looks really messy before you process the point cloud, so we're gonna do that. Okay, so now that we got this, as you could see, the brackets are pretty damn good. This is really all I need was this base of these. So I got it. Like, this to me is very good. And we have some other areas for the alignment purposes, which is awesome. Again, this really isn't my priority. It's these hinges right here. And now that I have them, and again, for me, the design of them isn't as important as how far out they go, because that's how I'll know I'll be able to perfectly align my side skirt that I design and fit to the OEM properties. So the first half is good. Now I'm gonna do the other half. And what I'll probably do is take the markers that I have here and like these up front and just offset them to the back just so I have more. More is better, what I'm learning. So again, project group, create a new project, and then we're gonna start there. All right, so now I am moving over to the second half. And actually, like, here's another marker I'll snag over and place just over here, because why not? I'm not using it in the other spot anymore. Okay, and then another triangle. I'll grab and place just really anywhere, doesn't matter. So just like the other one, well, I'll leave it because I'm running out of room. Press play, and we're off to the recording. And like I said, the halves are the only thing for alignment purposes. So I'm just gonna get a decent enough scan of this whole area of like the hinge and whatever, just so I could align it better. Now let's take a look at what this point cloud looks like, and if we have enough to say we're good. All right, no weird skips. We have this bracket, this bracket, this bracket, and then that one. That one we have, but we already scanned, so we're gonna do generate point cloud, and let's take a look at it. Okay, so this is what we have, and this looks pretty good. Again, the key ingredients that I need are right here, and they look pretty solid to me. So what I'm gonna do now is connected domain. Oh, see? Again, it's not connected, but I don't care, because to me this is fine. So it's very important that I get the key ingredients in the scan. That's good. All right. The hinges, I honestly, well, for alignment purposes, I'm actually going to leave them, because they're such a weird organic shape that's going to really help with the lining. Yep. So the hinges I'll leave. And then everything else looks pretty good in terms of not being needed. So we're gonna delete all that trash. There we go. All right. So I'll do a quick little apply edit. We'll do a clean process of that. And then we'll do a quick test align. Because if they do what I hope they do, then we're in a really good spot, because I could just flip this over, scan the bottom side, and then it's ready to be called a good scan. I'm gonna pause it. All right, and there we go. So there's our mesh. Now let's go to project 2 points, because I don't need this one. Hide that. Let's take a look at this one. And before I do anything, I'm gonna do the same exact thing, connected domain, because a lot of it is gonna have some lingering artifacts that I don't want, like back here. So we'll just do this, this. Again, the hinges I do want. That element I do want. All right, that's looking fantastic. Delete all that trash, quickly process it. All right, now that we have most of the stuff done, this last part is the last piece that I want to scan. So what I'm going to do is scan obviously the surface, but then the reason why I put it on the edge is so I could kind of go around the bottom and get a little bit more of the other side for reference. So got the scanner going for a project 4 scan. We're going to turn this on. And off we go. And the reason for this scan is because I want to design my side skirt to try to utilize this OEM mounting areas. Okay, so here is the bottom of the side skirt. It looks good. So what I'm going to do is just like the other one, go in here, isolate everything else. Hopefully it doesn't include the boxes. Perfect. All right. Delete selected. And honestly, I'm going to delete a little bit more than I need to, because I don't need that part and that part. All right, so that looks good. Process that real quick. And then what I'll probably do is align my main outside to the main bottom side, so hopefully those two will work. And then the inside guts will be a separate alignment file. And then in 3D Max, I'll just manually kind of find the best case scenario of both halves. Yeah, both halves. So yeah, let me pause the recording. Now that I'm done in the garage, I'm back on the desktop in the house, and I'm gonna process all the data that I just scanned. So my personal workflow, and this is just my personal workflow, is instead of using the master assembly or the master scan file, what I like to do is start a brand new project. So I have a folder called size skirt tutorial, or breakdown, whatever you want to call it. I'm gonna name this A. Now for the mode, you want to make sure you choose the mode, or at least with my workflow, I choose the mode that I scan the assets in. So for here, it was laser scan, so I select that. And then what I'm gonna do is, see where it says project 1? I'm gonna right click, I'm gonna remove this. Matter of fact, I'm not gonna remove it, I'm gonna delete it. Yep. Now I click open project, which is essentially like merge. And then I'm gonna go into my main scan, so side skirt laser. I'm gonna go to project 1, scan, open. And this is gonna load the project into this new document. So it takes a second and it's gonna pop up. So as you see, it showed up, and there is my first scan. Now what I'm gonna do is repeat the same process with project 2. Click open. Takes a second, and then project 2 is going to populate. There we go. And now you just repeat the same process with all the additional scans. So I have project 3 and project 4. And there we go. So now I have all 4 parts in the file. So now it's time to align all these scans, which are right now, as you can see, quite misaligned. So I'm going to go to project alignment. Then what I'm gonna do is I'm gonna start with my inside bits. And the reason why is because these are the most important for me when it comes to these brackets. So I have to make sure the inside is perfectly aligned, and then the outside and then the bottom is their own element. Now, because this is a plastic element, when I put it up on different boxes, if you will, based on me scanning it, it did have a little bit of flex. So it's not the software's fault, it's not the scanner's fault. The alignment is not going to be 100% perfect when it comes to the inside, the outside, and the bottom, just because they all had different angles while scanning. So now what I'm going to do is I'm going to click, instead of auto feature alignment, which you can do, I want to do by markers, just because to me this is going to guarantee the best that I could get it. So I'm going to go and put my cameras on the top right and the top left to be the best visual reference as I can. Now what I'm going to do is I'm going to hold, I think it was shift. Oh, sorry, not by markers, by manual markers. That's what I want to use. I don't want to let the program guess. I want to tell it what I'm doing. So I'm holding shift. I press on the top left on 1. I'm going to go over here and match it. So as you can see now, it's coded 1 to 1. And now you just repeat this same process on all the markers that you know are identical markers. So for me, that, then we're just gonna go, and I like to kind of spread it out at first so I have a good reference of what I'm aligning to, and then it gets a lot easier to sync it up like that. And what I also like to do is kind of give it X, Y, and Z coordinates. I feel like that helps the alignment, just because it gives you a good, or the program, a good reference of where all the elements live. You could overkill it if you want to. I'm not going to. So there we go. Now I'm going to click apply. And there we go. Now on the bottom right, or the bottom center view, this is our master preview. Now as you can see, this is perfectly aligned. Our brackets are overlapping seamlessly. To me, this is an ideal alignment. So I'm just gonna click next. There we go.
So now the other thing is the top left view is always the fixed view. This is not gonna skew or distort when it comes to alignment. The top right one does. So see where it says fixed window? That's the one that we always want to use as our master. So right now we still have two more projects. We have the outside shell and then the bottom scan. So same thing goes for these. So I'm gonna go to project 1, and now here's where we're gonna run into a problem. These aren't gonna align perfectly, and that's because of how the plastic kind of had a little of a bend to it, which is, again, no fault of the scanner or anything. It's just, it is what it is. It's how I set it up. So what I'm gonna do on this end, same exact workflow. I'm gonna go in, hold shift, 1, 1, 2, 2, 3, 3, and as long as I have more markers to add, I am going to. And like I mentioned, the whole concept of making sure you have X, Y, Z abilities. So there we go. And now what I'm gonna do is I'm gonna go to the other side, and hopefully I have markers to reference here as well, because this is just gonna help it align better. And some of these markers I added later on during the scan, so as you can see, I'm missing some. And that was just me adding them at the back side later on during the scan process. So now I have 9, and then what I'll do is just to try to help it a little more, I'm gonna add these two right here, and maybe this. And then, just for the sake of why not, that one in the mix, as well as that one. So now that we have that, I'm gonna do the same thing I did in the previous one. Click apply. As you can see, we are now aligned. Now, my outside edges are aligned the best they can. Again, we're bending plastic. So while it's trying to do the best it can, it's not gonna be flawless. And that's because of the plastic having a little bend to it. And so what I'm gonna do on my end on the design stage is export out. I'm gonna mesh these parts separately, so that way on the 3D side I could skew and distort the geometry a little bit to help it align better. And that's just me hypothetically unfolding the plastic or unbending it. So now I'm gonna click next, and the last piece, which is project 4, and this is the bottom belly of the side skirt. So same exact logic, going in, and the only hiccup I have now is, as you can see, we have a few, two different points overlapping. So this is kind of where you try to do the best you can with making a judgment call. At least in my situation, that's what I have to do because of how the plastic had a slight bend to it. So I'm just gonna wing it and assume that these are the points that I want to reference, and the scanner or the software is going to do what it can do, but it's definitely putting it in a position of uncomfort because of the points not being 100% accurately aligned based on the plastic one. That's what I want to be clear. It's not the scanner, it's not the software, it's the actual plastic of the side skirt and my workflow while scanning. So there we go. Now I'm going to this side, and this side, as you can see, aligned very well. So this was the less distortion area. And I think what happened was when I was aligning it, the software just chose to kind of say, okay, these points we're going to do the best we can to make it match, and the other one is going to do what it's going to do, and that's okay. So what's going to happen is we're probably going to end up with this side being our master beautiful side, and then the other side we're just going to fix in 3D Max. So there we go. I have 16 points. I feel like that's good enough. So again, last time we press apply. And there we have it. So as you can see, this side where the points kind of offset, it is what it is. And then this side, let's take a look. The points are more or less right on top. A little bit of a skew, but it happens when you're working with a thin element like this. So now I'm just going to click next one last time and click exit. And so now here is the full side skirt with all projects aligned. And now what I'm going to do is just manually export out sections. So this will be one object that I'm gonna mesh. Then project 2 and 3 is another element that I'm gonna mesh independently. And then project 4 is gonna be the final piece of the puzzle to mesh independently. Save them all out as independent OBJs. And then I'll show you how this looks inside of 3D Studio Max. Okay, so now we have the side skirts inside of 3D Studio Max. And as you can see, when we zoom in over here, this is where all of our alignment offsets were, which is okay, not a big deal. So what I'm gonna do is I'm gonna hide the side skirt layer, and we can see our actual 3D scan of the car that we've done again with laser mode. So this is the full car. And now the previous scan I have done, so it's going to be, let me find it here, 3D scan. So here we go. I have a good reference of this hole. The reason why this is important is this element right here, if you can see, and the side skirt, they all share this hole as a pin for one of the clips. So my logic is, as long as I could have this back end aligned perfectly, and then distort the front end manually to get this hole to be in this place, the fitment should be a whole lot better than what it is. And that's again because the plastic was flexing. So I'm gonna hide these. I'm gonna hide each one of these side skirt scans. So here's the first one. This is the outside shell. I added a modifier in 3D Max called FFD. And what this allowed me to do is just manually skew and distort the 3D scan. So I did that there. Then I hid that one. Opened up my other scan, did the same exact thing. As you can see, just pull, push. And then the last part, same exact thing. So now when I hide and unhide or show all the scans, as you can see, this hole is lining up very well. These edges are pretty close everywhere. So overall, this is a really good alignment now. And if I open up the 3D scan, as you can see, the hole over here is lining up. And then I have these things called pins, which are my cutaway elements for mounting. The pins are now matching up almost perfectly. So to me, this is a good enough alignment where I can start modeling from. So that is the stage of me fixing the 3D scan in 3D Max. And again, that was just due to the fact that plastic is a flexible element. So it was flexing while scanning or when I repositioned it. So going into it, I knew I'd have to kind of fake it a little bit later on the 3D side. So now comes the time for me to actually be designing. And I'm not going to do a whole how-to or anything of the design stage, but I'll kind of do an overview and breakdown of my logic. So the first thing I had to do was recreate these brackets right here. These are the key ingredients for the 3D scan to fit to the car. And that's what it was really critical for me, to make sure these brackets were good. So I separated out the geometry, so I only had the brackets to worry about. And then I went in and I remodeled the brackets. So here they are, brackets. Here are my final brackets. And because I am 3D printing the side skirt, I actually had to make the parts, as you can see, quite thicker and wider and bigger, and I added a slant to them. So even if I'm 3D printing at an upward or downward angle, the overhang is minimal and it could have the ability to kind of print without having supports everywhere. So that was the brackets thing. And then it came to the designing of the side skirt. So I hit the brackets and I started working with this scan right here, the P1. And I went in and I recreated the top segment, which is what goes underneath the door and kind of really hugs the body, the OEM body. And that was to me the very important part, so it has a really good fit on the car. And then after that, what I did was I started designing the actual side skirt. Now, because my fender, as you can see, so my fender, right here, I really wanted to add kind of like the GT3 RS floating blade look, how the GT3 RS has it. I'll pull up a reference. So right here, this type of vibe. I really wanted to add this into my design, and unfortunately, you know, this is just a WRX. It's not a really cool Porsche, but I'm gonna do what I can with what I have. So next thing was, okay, so I have that, and I really wanted the vents inside the fender to make it more obnoxious, really, this car, I'm not going for performance mods. My GTR is fast. This is just for looks, to have fun with. So that's kind of in a nutshell the design of the fender. But the key ingredient before I could start working on the rear end of the car is a side skirt, because to me, the side skirt ties the front and the back together, and it adds that blend with style, aggression, and also the transition element. So I really needed the side skirt done before I could work on the back end, because that's going to establish the rest of the game plan. So the way I like to work is I like to gather reference, and there's a few companies that I really look up to in terms of design, and I kind of grab a little here, a little there, and then kind of work on, okay, what I like, what I dislike, and what I could do to make my own version of it. So from Agile Design, they obviously have the front blades on most of their kits for the BMW and such. So for the BMW, this was a cool thing. And what I liked about their side skirt was this kind of indent right here, this line, the way it flows just adds a different little like characteristic to the design element. And then the blade was nice, but because I don't have such an obnoxious area to work with, I couldn't go with such a tall blade and still make it thick and all that. And then the rear end, because I have the door, so let me show you the scan, I honestly don't have really any real estate to work with creating a big blade the way the M4 does, just because of how my car is. So I was like, okay, I like the design of this, I like these body lines, but I gotta kind of change things around. So then I started looking at other companies as well. So that was a nice one. Then Agile has a Civic, which I kind of used as inspiration for the back end, because the Civic has the same situation, not a lot of meat on the bone back here. So it had to be a little bit more subtle. So I was like, okay, I kind of like what they did here on the Civic. So then that was a little piece that I got inspired from. Then there was another company that did a Corvette, not another company. This was the one that I got inspired for the fender design. I really liked how this came in, and then they also had the floating blade. So this was inspiration in the mix. So again, I'm just kind of picking and choosing here, there, here, there. And then the Virus one, I really liked the change in direction right here. To me, I felt this was really cool and a fun way to kind of create more edgy design lines. So again, I'm just prototyping. I'm kind of testing the waters and see what's working, what's not. So this was my side skirt design. This is what I came up with, and this is what I'm actually 3D printing right now. So this is what it looks like. As you can see, I have the blade, I have the transition and edges to kind of really like play off the light and reflections and highlights. I have this body line that I added down here. I added an additional floating blade back here, but it's right at the height of the door. So if we go to the side view of the car, as you can see, like the clearance is almost not existent. And that is the game plan, where I'm pushing the limits of what I can with fitment just because of the 3D scan. And I'm trusting that this will work out very well for me. I hope so. So that was the game plan there. And then because now I could work on creating the wide body rear end design and kind of add a feather blade type of feather to kind of help blend in the purpose of that shark fin, if you will. So this was my design on the 3D side. And then after all the remodeling and such, this is how the back side looks. So I'll show that. And again, for me, my goal is to try to make it as OEM fitment as possible. So this is where I ended up with. So as you can see, and once the side skirt has thickness, you can see that as well. But I'll actually open up the file that I'm 3D printing. So let me show you that. And here it is. So this is the 3D file that's on the printer now. And after some cleanup, because I had some issues and some blending, this is what we end up with. So as you can see, my goal is as an OEM part as possible. I'm using the OEM hinges, OEM mounting points all across the bottom, trying to recreate the OEM indents, shapes, cavities for the lifting points. I want this to fit perfectly with the OEM. And now the reason why you don't see a front blade is I actually cut it out. So that way when I'm 3D printing, I don't have to worry about cutting the blade off in the slicer program, because then it's going to create a cut on the side skirt and such. So I'm just cutting it manually in my program. So I cut it like this, a perfect flat cut. And then I just do the opposite, so intersect. And then this is my second 3D print object that I just export out from 3D Max, which is just the blade itself with a perfectly flat base. So it's easy to put on the 3D printer and print without any issues. But as a whole, this is how the side skirt looks. So that in a nutshell is my design logic and workflow. And as far as like the topology goes, I'll show the wireframe. I try to keep it pretty simple. It got a little more dense up here just because of all the edges I wanted to preserve. But then when it comes to the complex areas, I try to keep it very minimal so it's easy to adjust and modify, and hopefully keep as little of a minimal issue with pinches and bumps and all the things that poly modeling has to offer when you do it. So as you can see with the doughboy or the gray, and I'm moving the highlights, overall it's a pretty smooth mesh. Never as good as a NURBS model, but I'm happy with it. And granted, when you're 3D printing, it's melting plastic, so there's going to be issues with seams I got to feather off. But as far as a foundation that I could provide, this is very minimal with any pinches, bumps, lumps, things like that. So happy with the geometry. It's 3D printing, and you'll see it in the beginning of the video with me test fitting it on the car. So any questions, feel free to post in comments. I always read them because I don't have a lot of followers. So what I could do is just kind of share my information with the community and respond to any questions I can. Thank you.